G'day and welcome to Mark and Sam After Work. Today I want to do a video discussing the differences between lead core and monolithic bullets. So the normal swaged lead core with copper jacket bullet versus the solid metal, solid copper, solid brass, solid steel, but monolithic machine bullets. Over the last few years we've got more and more down the road of solid bullets, monolithic bullets. And I think most people's understanding is of the precise machining that we can do that makes these bullets more efficient, better bullets, but they're more expensive. So people only resist using them because of the expense of them. And I suppose that's a little bit what this video is about, to go through and explain those differences. Well, to start off with, what I would say is that yes, you can, with the monolithic bullets, they have a lot of control. They are able to, with CNC programming and high-level CNC machines, able to produce exact copies of each other, very good bullets made very well. But it isn't all positive with a monolithic bullet. The positives are, yes, they can be exactly the same. They're machined out of one piece of material, so that is good. There is, as most people realize, the expense side of things. They're starting to answer that in places. But the actual truth of it is that a lead core bullet has advantages also. To start off with, lead is a very, very heavy metal. So its weight versus its area means that that's a little win. With a bullet, one of the things it's fighting is, no matter how smart the shape is of the outside of the bullet, which what I'm talking about there is you get a higher BC bullet, which means that it's basically, in a very crude way of describing it, it's shaped so well that it actually travels through the air very efficiently. You can imagine a brick traveling through the air wants to stop pretty quickly because it drags and it tumbles and it doesn't flow very nicely. Whereas if you shape it very well, it travels better. So that's where you can, yes, have an advantage there, but you also have an advantage versus the weight. So if you built yourself a foam bullet and tried to throw it, it wouldn't travel very far at all. When you've got something like lead as the mass, then it would be very, very heavy versus its size. So once you get it traveling, it stays traveling. Its inertia keeps it going for a lot longer. So that's one of the advantages that a lead core bullet has, that heavy mass on the inside. Another advantage that it has is because it's soft with just a thin jacket of copper on the outside, means that it actually seals to the barrel better. Now, what we're talking about there is that when a bullet is fired, there's a lot of force behind it that actually deforms the bullet a little bit. And that means that then it pushes out and seals to the barrel a little more efficiently. Now, with the monolithic bullets, you'll see things like drive bands and things into the side of them machined to try and give you the best of both worlds. You get a precisely machined bullet, and it has a little sealing ring on it, a little drive band that actually comes out and actually cuts into the rifling, which means it does that very efficiently, which works quite well. There is a little side effect to that side of things, and that is that once you've gone out to subsonic flight, where the bullet has slowed down, so in ELR shooting, those little drive bands become a negative out in the extreme long distance shooting. And that's simply you've gone from supersonic flight, where you have a sonic cone protecting the bullet as it travels through the air. When it slows down to subsonic flight, it goes into fluid dynamics, where the air is rubbing heavily on the bullet again, and at that point you actually have any deformations on especially the bearing surface, but anywhere on the outside of the bullet, will cause it to be less efficient in that sort of travel. So there's a yin and a yang that goes to that side of it. Another detail, and I suppose the other thing that we're dealing with here, years ago, and it's getting better and better as we travel forward in time, is the bullet production, the quality control, the process that they go through, the learning and the efficiency of swaging bullets is getting better and better. They're getting more and more control to where they can, not completely, but start to rival the consistency of a machined bullet. There's a lot of expense in doing it properly, which is why you start to spend more and more money for better quality lead core bullets, but they are starting to get where their swaging processes, their quality control, so their machining process to build their dies, all that sort of stuff, are lifting further and further and further to where you're starting to run into very efficient lead core bullets. But it is a big deal, and certainly in the small bullets, it is a big deal as to how efficient they are at sealing to the barrel. So where that deformation of a lead core bullet has a real advantage over a monolithic bullet, especially in the small bullets. I suppose another thing that I find which does seem to influence things to me as well, and that is the swaging process and pushing the material, especially the copper I'm particularly talking about, through those swages, actually through the dies I should say, actually smooths out the copper. So it ends up with a very, and I think slightly hardened surface to the outside of it. So when it comes to loading a lead core bullet, if you've set up everything to the right sizes, got everything right, that really smooth outside that you get on a lead core bullet, that smoothness and toughness of the outside surface of the copper loads very easily. You'll tend to find, for those that are experienced and done a lot of loading with monolithic bullets, that's a lot harder part of the process. Even with the finest machining, it is still just machined. So it's raw copper that has been machined, or brass, or steel, or whatever it is. You tend to find those little machining surfaces just make it harder to get the brass to get them to load. You have to do more work in that place. Also, you'll find that when you're actually pressing the bullets in, unless you've done a lot of work with your seating die, you tend to mark the top of the bullet, or on the secant, on the down from the tip, wherever it's pushing down onto. That tends to mark very easily because you do have where a cutter has been. There's very fine microscopic little points of where the cutters run that are on the outside of the bullet. Different coatings and things like that can help in that situation, but in a lead core bullet, that's all sort of taken care of. Another detail on the lead core side of things, which I've got a few here, are the tipped bullets. Something that was, listen, Hornady are the main people that are doing that sort of stuff, getting better and better at what they're doing, and there's a little bit of the way it's coming together is you're getting a little bit of both worlds. They have almost, well, I think it is a machine tip that's going into the bullet, so you're getting nice control over the tips. You still have a problem of, which getting better and better, but of the joint between your tip to the bullet. It's a very important part of the actual efficiency of the bullet, of the ballistics of the bullet. That little point there, that little join there, is something that is a feature that is a little negative. They're starting to get on top of that. I would still tend to go with, if I had the choice, then I would tend to go with a one-piece lead core bullet versus a tip bullet. I tend to find a little bit of extra consistency there, but that is starting to, we'll see that with the new Hornady A tips, they're certainly up there. I still think it's that way, but I haven't really finished the testing properly there. So that's the basics of the difference between the bullets. I would go into what I've found for myself is that really I think it's somewhere the 338, 375 is the changeover point of what I've found, where the monolithics or the solid machine bullets have a little advantage in my experience so far above 338. So in my 375s, the 416s, the 50s, in those sort of size bullets, I use monolithic bullets. It's a little bit, I think, in the theory of it, that because of the large size of the bullet, you start to the drive bands, the lack of deformation, all that sort of stuff are not as enough as a negative as the positives of machining them. It's a weight versus size thing that starts to win at that point. Below that point, the certainly in the 338s down to as small as you want to get, down to the 22 cals and 17 cals, then the lead core has I've definitely seen a win when I've done the comparisons there. That lead core, that the energy of the inertia of that extra weight, the obturation, which is talking about the deformation down the barrel, all seem to be a win on that sort of score. The bit I would have to say, which means my testing isn't solid and completely sorted on that front, is that there isn't really good lead core bullets in the big stuff. The lead core bullets tend to be slightly less efficient. They tend to be more ball ammo, tend to be more just a military or a machine gun round, so they are, in the big stuff, they tend to be less about the extreme precision, and really the only stuff that's taken over or doing that properly is in the monolithic bullets. So maybe it's simply, if there was someone building really good bullets in the lead core, I would still see an advantage there. But from what I've seen and from what's available, no, that isn't the case. It really moves into, like I said, really above 338 is where I go with the monolithics, and below 338 I've found a win in the lead cores. My testing is only my testing, only what I've seen. Those are my logics to go with it. I suppose there is one more piece I would say to go with that equation, and one of the other reasons it's going on is to get high ballistics. You need to run a longer bullet. To get really good ballistics, you need a longer bullet, which happens pretty easily in your small snuff and up to 338. But once you go into the top end of your ballistics in the bigger calibers, you'd also need a very, very heavy jacket to deal with the amount of twist. What I'm going there to explain that quickly is that the part of the deal is the road to with more twist. If you're talking about an average twist of let's say it's what we're running into a lot nowadays, a 1 in 8 twist on a 7mm or a 6.5mm caliber. You need that 1 in 8 twist. The bullet's going to be traveling at somewhere around the 2800 feet per second. You're talking about something that has an RPM of over 250,000 RPM. That's the revs per minute. So extremely fast RPM, 250,000 revs a minute. That means that if you've got something solid, that doesn't really change anything. It's solid. It would deal with a lot higher RPM before anything happened, because it doesn't have a deformation thing. That same thing that helps it seal the barrel is also, once you start spinning too fast, and that's the lead core, could actually blows bullets apart. So getting complicated, but what I'm actually saying is, in the bigger stuff, you'd need very heavy copper jackets to be able to deal with the RPM needed for the high ballistic bullets, ballistic coefficient bullets. So that's really why you don't see them, because that would be another level of complication, whereas actually the monolithics do that very well. So the solid copper works above the 338. So that's about what I can tell you. I hope that makes some sense to people. For me, I try and find the last detail I'd go with is that in those smaller bullets, in your 338 down to your 22 or 17 cals, that sort of stuff, the spending a bit extra on a better quality bullet is a very valued thing. Consistency, the level of effort it takes to swage bullets in very consistent and very precise tolerances does cost more, and that's why that expense is there. But you end up with the win in the way of how consistent that is onto target, where it travels better because of the weight, because of the size, because of the balance, because of all those bits and pieces are more consistent, is the reason the bullets travel better. Anyway, that's my little overview on lead core versus monolithic, and that's my take on it. Thanks for checking in on us, guys. We'll catch you next time.